I would like to talk to you about mprobe. So in essence, how to move from a packet or a flow capture, analyze it with DPI, and generate some flow analysis. Okay, so you know that ntop has several tools, and today I'm going to talk about mprobe basically, and in a limited part about ntop that we have not mentioned today. So, you know, probably the most popular one is this one, DPI, but today this is the topic. So what is mprobe? mprobe is one of the oldest, probably the oldest software that we developed. It has over 20 years. It is an application that was designed initially to replace a Cisco router in terms of flow export capabilities. Because Cisco were a little bit limited, expensive, at that time, 20 years ago. Limited, expensive, and not everybody had them. So we came to the conclusion that when everybody was moving to the collector side, so there is a router that is sending me flows, and I just need to collect them. We thought that probably the best was to go the other way around. So in essence, to look at the probe. So that's why we call it mprobe, even though today it's also able to collect flows. It's able to do that. But the main focus is to be a probe. A probe means that it captures packets and transforms those packets into flows. So, is this still a good idea? We think so, for various reasons. First of all, because mprobe is sitting on top of NDPI. So it means that we can do deep packet inspection. That initially for us, the packet inspection was simply to label TCP port 80 as HTTP. But now DPI means much more than that. So for instance, we have a security risk. So it means that for every flow that we monitor, we also label the flow according to some cybersecurity problems we see. Something very simple such as, I don't know, a TLS certificate that's expired, to something more complicated, similar to what Alfredo showed this morning, so a data exfiltration over DNS. So this is a bonus. And contrary to Suricata, where there are some rules, we don't have any rule. So it means that what we label is labeled because we see something unexpected in the traffic, not because that there is a rule that says it's unexpected. So this means that even if we have some traffic that, let's say, is unknown to Suricata because there is no rule, we might trigger an event because of that. Of course, we don't have any rules doesn't mean that we have zero rules, because in a way the blacklists are rules for us. So, or the DGAs are rules for us. So if we have, let's say, some sort of pre-knowledge about a specific information that we believe it is not good, such as, for instance, a blacklist. The blacklist says, if you go to this website, this is going to be malware. So for us, this is somehow, in a way, a rule, but it's not a rule. In essence, that we don't have, as you have seen in the previous presentation, a very complicated pattern to fulfill in order to trigger an event. So in our case, mprobe, based on NDPI, labels traffic as suspicious, or let's say with risks, if there is something that we don't expect to see. So the first option here of mprobe is to transform packets into flows and export them in JSON format, in NetFlow, in IPFix, in whatever. So the second is to collect flows and to re-export them. So it's a translator or a proxy if you wish. So if you have, let's say, a very old collector that has to speak with a very modern device, so this is the transformation. Or if you have, let's say, a vendor device that is triggering or is generating flows with information elements that are not standard, mprobe can clean up those information elements and re-export the flows into a format that makes more sense. Of course, we can collect flows and dump them to disk or stream them to a remote collector. I will show that in a second. And through a flexible plugin architecture, it's possible to have some specific dissector for specific protocols. Let's make an example, diameter or radius, HTTP, this type of protocols, where we export metadata for those protocols. It's one of the oldest protocols, as I said. It was initially considered as a drop-in replacement, but over the year, we have two versions. The first one is what we call mprobe, just it. We call the classic mprobe because it means that this version is the one that was created 20 years ago and that is able to operate up to 10 gigabit. Why that? Because mprobe has various components, and mprobe it is flexible in terms of internals, so in terms of plugins that people can extend it. So this means that this versatility, the ability of analyze a lot of potential information, is paid in terms of performance. So while 10 gigabit it's quite a high speed that not many people have, it is nothing compared to another version we call Cento, that means 100 in Italian, that is designed to operate at higher speed, so 40 to 100. So let's say there are two versions, and I'm now going to tell you what are the main differences. Both products sit on top of NDPI, and they are available for many platforms. So we mainly operate on Linux. We expect people to use Linux. But as I've said this afternoon, during my first quick preview of the ntop Cloud, it is able to run on all those platforms. Tomorrow you will see, for instance, a presentation from an American company called Catchpoint that will show how to use mprobe on operating system used at the desktop, such as Windows or macOS. The architecture is this. So in essence, it's a gateway that can receive flows from various types of devices. Flows are unencrypted. So a flow is something that was created many years ago on the days where clear protocols were standard. It's not like that today. So mprobe can receive this data or can collect the packets from the network, so simply capturing traffic, and re-export them in various formats, either to NDPI, or to other type of consumers. That can be either a router, if it acts as a proxy, or to, let's say, a remote Elastic instance, or to Kafka. And they can be encrypted, optionally. So you can have encrypted or unencrypted. So it can be a gateway, or it can be a source of transformation from packets to flows. Just to give an idea of Cento, I don't want to talk too much about Cento today, but just to give an idea. The main difference between mprobe and Cento is that Cento, if it wants to go fast, it cannot have many options. Okay, here it cannot have too many options available. So what Cento does is the following. It first of all captures packets, no flow collection. So if you want to collect flows, you need to use mprobe. Capture packets from multiple interfaces. mprobe can use only one interface here. So this is quantity 1. So if you have multiple interfaces, you need to start two mprobe instances, or to aggregate traffic, for instance, through ring. So capture packets and transform them into flows at a very high speed, so 100 gigabit. Can also handle multi 100 gigabit if you have a very fast, very beefy server. Cento can also speak with ntodisk to export packets and metadata, and can also take selected flows and forward them to remote applications such as Suricata or Zinc. It has many more features, but just to give you an idea that Cento is just an application that takes packets, transform them at a super high speed, 100 gigabit to flows, and deliver them remotely. Of course, also to ntopNG, this I didn't mention, but I assume that all our tools are able to speak each other. So let's forget for a second Cento. As I said, today I want to talk about mprobe, and let me start from the beginning. So what is a flow? A flow is in essence a way to compress information. So instead of having individual packets, we compress them in a format that contains a summary of this information. So a flow contains, for instance, counters, such as byte and packet counters. This is the minimum information I expect to see. When it started, when ended, the interface from which this traffic was captured. Originally, as I said, mprobe replaced a Cisco router. So because it has, in terms of traffic analysis, because of that, a Cisco router is accounting traffic when the traffic is routed to it. So it means it has to enter from one interface to another interface. It has some QoS information, very simple one, like type of service protocol, and of course it has the actors who is doing that from to the application that initially was labeled based on the port. As I said, today we also have DPI. DPI is reliable. The port it is not reliable because you can put your web server on port 4000 or on port 443, and instead of having HTTPS you have HTTP, and the other way around. So in essence, this is somehow an unreliable way of binding application name to product. And then we have routing information. This is only if you are a router. mprobe has limited visibility of this information. Okay? So the autonomous system, for instance, are computed using a file, a configuration file, such as those that we use for geolocation. Or can have a plugin that speaks with a router, opens a BGP session, so the router is sending to mprobe BGP information, and mprobe is labeling the traffic according to that. It is used very seldom, but some people do it. A flow life cycle is the following. So this is the initial packet. So whenever a packet hits a router, if the packet is routed through the device, okay, is considered, otherwise it is ignored. In this case, the packet is decoded, okay, and then once it has this information, the packet is searched in a NetFlow cache, so in a memory inside the router that contains the key. The key is usually that or a subset of that, and that contains some counters. Whenever there is a packet, increments the number of packets, increments the number of bytes. So the flow starts as soon as one packet hits the router with this key. Okay, imagine this as an hash table. This is the key and these are the values. Very simple. And then a flow is terminated when one of these conditions are met. So in essence, if you have a TCP flow, for instance, there is a fin flag. Note that a fin flag does not mean that the flow is over. It means that the flow is about to end. Because a fin says in a polite way, I'm gonna stop. Okay? So I'm telling to my peer, okay, you send me whatever you have in the buffer, and then we are gonna end the story. But fin is not the last packet. Okay? It's one of the last packet, but not the last one. So this is interesting, but somehow it might be misleading. But for sure, when the flow lasted too long, so you put a default duration, okay, maximum duration, or when the flow has not been active for some time. So in our case, in mprobe, we use this information, okay, on the command line to specify the timeout. So in essence, we specify timeout with -t for the lifetime. Let's say if a flow is lasting a long time, like now, for instance, we had this streaming over Teams, okay, that lasted half an hour, something like that. So if I put a timeout of 120 seconds, so it means that every 2 minutes a flow is exported by mprobe to the remote collector. This is very important. I will tell you why in a second. So a single flow is divided in subflows. The second flag is the idle timeout. So when a flow is idle for some time, I want to remove it from the cache. So by default, mprobe uses 60 seconds, but this is really up to you. So these flows are not sent immediately as they are exported, because we want to save bandwidth. So they stay in memory for a little while, and it is specified by the queue timeout. So by default, it's 30 seconds. This because in a packet, mprobe is able to store several flows. With NetFlow version 5, there are 30 flows per packet. So instead of sending one packet per flow, mprobe waits until 30 flows are received, are ready to be exported, or until this timeout is over. So let's say I wait a little while. If I can put 30 flows in this packet, I will send them out. Otherwise, if 30 seconds are passed since the first export, I will send the data anyway. Now, why do we have this information? Why do we have to cut a long flow into smaller flows? What's the reason from your point of view? Why that? Why instead of sending several flows, we don't send just one flow at the end, but we divide in subflows? They all have the same key, because if I go back to this one, they will all have, because the flow is continuing, okay? So they all have the same key. So why do you think it's important to divide it to subflows? Don't think as a flow, as a probe. Think about the collector. What does it happen if a collector, or if I specify the timeout of 1 hour? This is going to be a question for the next capture to flag.
Not with data.
Right?
Not with data.
if the collector is talking with a probe and has a very long timeout, so it means that the collector, if it's 1 hour, will be blind for 1 hour until the first flow is received. So it's important to split the traffic, okay, into subflows so that I periodically inform the collector that things are happening. And there is a second reason. So imagine that you write a time series. So imagine that you create so imagine if you want to create a time series of the traffic that is flowing in your network. I've shown you before here that the flow contains the beginning and the end. Partial end. So, if I am at time 0, I want to have 1 point every minute. So, point number 1, number 2, number 3. How do I have to tune the maximum duration so that I receive 1 update per minute? Can I use 2 minutes, for instance, lifetime timeout? Make sense to you? Not really. So if you want to have a time series like that, you must send, if this is to the collector, you must have various updates. The more updates, the better, because I designed it like this, but in practice it will be like this. It will be something like, you see the update, it will be like this. Okay? So the more updates, the smoother is the curve. So think that if you have a long timeout, you will save bandwidth. Because instead of exporting multiple flows, you will export 1. But on the other hand, you will not be able to have like that. Also, the collector will be blind. So if you have ntopNG that is talking to a probe, I showed you today in the cloud, you put 2 minutes or 5 minutes, you open ntopNG, there is nothing happening, but it's 5 minutes you're using Teams. So this is the result. So that's why it's important not to have timeouts are too long. Every 10 probe, you can use -T or -D to fix them. This one, it's another timeout. It's just internal, I would say. Don't put it too long, but these two are the most relevant ones. In fact, many times we speak with our users, they complain that the graphs are not nice, or we see a spike in traffic that is above the capacity of the network. This is because they use very long timeouts, okay? And because the time moves on, so at some point here, I receive an update for a flow that lasted 1 hour, okay, that gives me a lot of data, much more than my last. But this traffic was supposed to be split over 1 hour, but instead it is compressed, and the only thing we can do with the collector is to do something here. Otherwise, what I had to do was to go back in time and talk with them, but this is inefficient. Also, going back in time is wrong, because I don't know if this traffic was sent a very little bit per second there at the end of super spike. So to make things simple, don't keep it too long, 1 minute, 2 minutes maximum, if you want to have a smooth curve. Stop me if there is something wrong, please.
What if you flows super short, or even if you set your packet instead of flow? It makes sense?
Let's say it doesn't have to be too short, because otherwise the advantage of compressing data with flows doesn't make sense, doesn't work. So it should have to be something in the middle, 1 minute, 2 minutes, I would say. 30 seconds, not below 30 seconds, for instance, but not above 2 minutes. The amount of traffic that is generated by the flows depends on various, let's talk about NetFlow version 5, the simplest one. So with NetFlow version 5, you can fit 30 flows per packet. So it means with 1400 bytes, 30 flows, okay? So let's say you have to make a computation. There are various websites. If you go to Google, say net flow bandwidth calculator, it gives you an idea of that. But the amount of traffic here will be a few megabits. Okay, even if you have a large network, it's not much. It will be 1%, 2% of the traffic you're monitoring. Okay. Any other question? Okay. mProbe can work in 3 modes. First one is the probe mode. So mProbe takes packets and transforms packets into flows. Okay. The second mode is the proxy, collects flows, massage these flows, and send them out. With some changes. As I said, for instance, some information elements are removed, other are fixed, things like that. Or can be a collector, a pure collector. So receive flows and let's say saves them into a database or to disk. These are the 3 modes. So let's see why these 3 modes. What's the use case? Probe mode. A use case is, for instance, you need to monitor traffic on a remote network and send flows to a central location. So you put your mProbe on your PC, as I showed today. You capture packets. You create flows out of those packets. Again, a flow is a way to compress traffic. Compress not a legit zip, because compress with loss. So you lose information, and you keep what is relevant for you. Okay? It's a very good thing, because otherwise, the faster is the network, the more information you have to monitor. But in this case, the probe is pre-processing the data for the collector. I mean, the collector cannot keep up at 1,000 gigabit, 1 terabit, whatever, or 100 gigabit, unless somebody is pre-processing the traffic. So this is the idea. And another use case is you doesn't have DPI, or you want to do cybersecurity analysis. This is very important because today, as I said, deep packet inspection is very important, not because we believe on that, but because it gives you visibility on your traffic. Because many protocols today are basically very general. For instance, QUIC or TLS in part is the new TCP. So if you have to do something today, why use TCP? Use QUIC or TLS. And they are very generic. They can be used for a VPN, they can be used for accessing a website, and used for many other things. And unless you go inside and you check what is happening on that protocol, honestly, you're blind. You don't know what's going on. Many people today are migrating to the cloud. First of all, they buy, they sign up a contract, they buy the service, and then they complain because they are running out of bandwidth. So they want to know how much traffic is going to the cloud, or what is the latency towards the cloud, towards my cloud I'm using. So DPI is very important. And most of the routers don't do DPI. A side effect is that DPI is not standard. There is no standard for that. One day we should try to write some sort of RFC, whatever, because let's say, Fortinet DPI has nothing to do, supposing that it works, has nothing to do with Palo Alto DPI, with our DPI, with Sandvine DPI. So why TCP is TCP for everybody? Here, it's already questionable, okay, how to label a certain traffic. Another reason is your router has limitation or, let's say, bugs. Let's call it bugs. So, for instance, a Cisco router, for instance, like the Cisco ASA, this is not a real router, it's a firewall. So it means that in this case, what I told you before, so this one is not true. Because in ASA, but also in other type of firewall, a flow is emitted at the first packet, saying, okay, there is a new flow, and this is the first packet of the flow, and at the end of the flow. So many users complain, because of the graph, because of many things. People say, hey, there's a lot of traffic, I see nothing. Simply because of the nature of this device. The device is exporting flow at the end of the communication. So if you download a huge file that takes 1 day, you will see the first packet that creates the first flow of this flow, so with 1 packet, and then after 1 day you will see a flow that so many gigabytes of data. So, but because this is a firewall, so it creates a rule that says, okay, the NAT or whatever say is allowed, send the flow, and when the flow is over, that's it. But no intermediate update. This is our problem. And then there are some vendors But, you know, every release they add a new feature and they add a new bug, and they fix a bug and they add a new bug. So it's a continuous fight. So ignore it. Or your router is working fine, but it is able to see only a subset of it. So especially high-speed routers, by even at 110 gigabit, the router is focusing on doing its job, so in routing traffic. And the engine that is taking care of NetFlow is limited. So only a subset of the traffic is going to this engine, and this is called sampling. So a few packets are selected, not all of them. So the flows are computed on a subset of it. That is fine if you want to have an idea of what is happening, but it's not fine at all if, for instance, if you want to do DPI, or if you want to have, you know, very good visibility. So this is very important. Most routers are doing that. A typical sampling rate is 1 out of 1,000. So you will see you lost almost 1,000 packets, you see only one. So it's not very precise, let's say. It's not too bad if you want to say, you know, in big numbers you see reality in a way, but it's not correct. Okay? Or if you want to compute advanced statistics such as, for instance, voice quality. So for instance, if we wanted to measure the quality of the previous team's call, was it good or was it bad? It's not possible to do it unless you see all the packets. No way. So this is one reason why mProbe is still one of our popular software tools, because people want to have good visibility. Okay? So when mProbe runs in probe mode, okay, it is very simple. You specify -i, the interface name from which packets are received. And you specify -n, the collector IP and the collector port. So in this case, mProbe is taking packets, exporting them in NetFlow format, the remote collector. Note that in this case, it's the classic mode. As I said, flows are not encrypted, they are not encrypted because we have to follow the standard. Okay? So, if you don't have a router able to do that, you can do this. You put mProbe on a machine, take the packet and transform it into flows, and you're happy. Many companies have big router that is taking care of the main branch, and they have several remote locations with small routers that don't speak NetFlow. So they put mProbe on a remote location and they complement the visibility this way. Note that you need to collect packets here. So it means that here mProbe must be able to see all your traffic. So you need to have a port mirror, a network dump, or some tricks to send to mProbe the traffic of your network. This is very important. Sometimes it's not feasible. That's a good reason to have mProbe as an agent. But this is the classic way. Okay? Another option is to speak with ntopNG. So instead of exporting in NetFlow, you speak with ntopNG over 0 and 2. You can optionally encrypt the traffic. It's up to you. If you're on a LAN, maybe you can avoid that, but if you're on a WAN, please encrypt it. I showed you before on the demo with the cloud that you need to put encryption key. I can show that another time if you want. So in essence, say -i internet. Instead of having -n a remote APM port, say -02 and specify where to send those flows to. And the ntopNG side, you have the same thing. So in essence, here you specify APM port. Instead of star, you can put the IP address. I will talk about this in a second. But in general, it's the same. In proxy mode, it's more or less the same. You collect the flows, -3. They are received, they are massaged, and they are exported again. -1. Now note that in collection mode, mProbe can support the various versions of NetFlow, IPFix, and SFlow. So you know what are the differences between NetFlow, IPFix, and SFlow? Are you familiar with that? Not all of you. So in NetFlow, I've shown you before some slides ago how it works. The first packet received, create the tuple, export, blah blah blah. IPFix is just a different format for NetFlow. So it's the way it is exported, but the idea is just completely the same. SFlow is totally different. S stands for sampled flow. So this is something typical that you see mostly in switches. It can be also in routers, but it's mostly on switches. NetFlow, as I told you before, is for routers, so the traffic has to enter and to leave the device. A switch is different. And because a switch has a high capability, let's say if you have a 48 1 gigabit port switch, you have 48 by 48, so 96 gigabit of traffic potentially to handle. It's a lot of traffic. So you will have a lot of flows. Most of the flows are duplicated because probably two machines are talking each other over the same switch. So SFlow is working a totally different way. Instead of computing the traffic, as I told you before, the flow cache, create the entry, export the entry, SFlow does this. Takes one packet out of whatever, for example, out of 1,000, out of 4,000, out of 10,000. This is a configuration option from the switch ports and export this packet to the remote destination. So in this case, Pro receive one sample, so one packet cut to a certain length sent by the device. So in this case, we don't have a real flow, but we have a packet here, a packet there, that gives us an idea of what the traffic, the original traffic was. In addition to that, we also have traffic counters. So I know per port how much traffic was delivered. So it means that the remote device can upscale traffic. So it means can expand the traffic to the original one. So it's the same thing that happens, for instance, when we vote, we polling. Okay. So we'll go to vote. Anyway, people are willing to know the result immediately. So after the vote ends, there is something called exit poll. Exit poll are computed exactly the same way. So instead of looking at all the votes, that takes a little bit of time, they take a subset of the votes, taken in a random way, but in a nice way, so not all at the same place or at the same town, in a random way, so just to give an idea of how the votes are distributed. The same happens here. So with SFlow or sample NetFlow, you can have an idea of your traffic. It is not very precise, but the more exit poll, the more precise is the result compared to the final result. And here, the more flows are sent, the better is the result of your analysis. But it will never be precise, because this is a sample data. So, to make this long story short, Dash 3 and NetFlow, IPFix or SFlow are received by Pro. Pro is handling all those tiny details and transforming them into something that everybody can understand. In collector mode, we have various options. I will now discuss in a second. Okay, collector means that Pro is the final destination. The flows are received, are massaged, and then they are sent to somebody that can do something with it. So popular things are a database. So I receive the flow starting with a database. Or I deliver them to somebody, also to the cloud. How? One popular way is using Kafka. So you asked before about, are the flows stored somewhere, blah, blah. Kafka has this ability. So in essence, Pro speaks with something called Kafka broker. So that is a server with some sort of storage. It can be memory or disk. And so the flows are delivered to the Kafka broker, and the Kafka broker, whenever it's possible, is delivering them to the remote end. It's a server, like a database. Another popular system is Elastic. So Pro is generating flows are sent immediately to Elastic. With Kibana, for instance, you can visualize them in a dashboard. So there are various options now. I will display them in a second. So in essence, in collector mode, there is no ntopNG, nothing. Flows are received and sent to somebody else. Data here is usually delivered in JSON. So let's talk about Kafka. You send data to a Kafka broker, and with Kafka there are several things you can do. So for instance, there is something called KSQL. K stands for Kafka SQL. So you can say, instead of sending all the flows to the remote end, do a periodic query on the data on the fly, and the result of this query is sent to the remote destination. For instance, if you want to compute the top token, doesn't make any sense to send all the flows to the remote client. But you can say, out of the last 10 seconds, compute the top tokens and send only the top tokens. So there are many things you can do with this data. Now, when you want to collect data, this -3 or collect report has various options. Okay? I will do this later, so I don't want to mention that. You can collect flows over EDP, CT, PLS. You can do many things. Okay, let's say this to say that all the various flavors of net flow that some probe support are supported here. We support TCP, UDP, and SCTP. That is another protocol used by some routers. Anyway, we support everything. But as I said, you specify a port for a port like this if you have multiple interfaces, and nprobe will massage the data for you on your behalf. No need to specify this router is sending me as flow, the other one sending V5, the other one V10, and nprobe does it for you. So this way, it's a good system for feeding something called data lake. So a place where you send all the data, and then somebody is doing super queries at the end to match the data together. So with Elastic, you have the special Elastic, you specify the type, its name, URL of Elastic, eventually username and password. Every, let's say, address has its own requirement. For instance, you have a Kafka, you specify the broker or the brokers, something called topic, so the where you send data to, and some other things such as compression, TLS, non-TLS, acknowledge, many things. But these are very relative to the configuration of these two guys. Another option is to write to syslog in JSON format. Why that? Because it is popular in some situations. I will talk about that in a second. Let me complete now this -3, this ingress. So this right here. Okay, so I talk about port, now I'll talk about this. So -3 apart. What is that? Amazon, okay, has created this sort of net flow they call VPC, that in essence Amazon does not allow you to do net flow on the instances. Or let's say it's something not very popular. What Amazon does, it creates some files in this format, so text format, that contain some flow-like information in a proprietary Amazon format, AWS format, okay? But people are used to use NetFlow or IPFix. It's not possible that every company has its own format. So nprobe is able to convert this information. As you see, it's probably more accept because somehow it's a firewall like Cisco ASA. Okay, so this flow was accepted from this host to this host to this file and so on. So nprobe is able to do that. Usually those files are put on an S3 bucket, so they're not on a real file system. So nprobe has to go and take them. Usually there is a process that is moving them. So nprobe is reading them sequentially as soon as they are created, and then transform them into flows. Of course, respecting the timestamp. So somewhere there is the timestamp. Yeah, there's the timestamp. Okay, but yeah, again, this is something super special for Amazon. But if you are running on Amazon, this might be relevant for you. We also have something for Google Cloud, of course. Eventually something for Azure, but this is something that in a second. In this case, we have something different. Google does not have a special format, but we have a converter that is able nprobe to write into something called Google Cloud PubSub. Okay, that is used for storing flows. So we have some customers that are using storing flows into Google Cloud. So in this way, we write into Google Cloud. Again, this is a protocol. Anyway, this is the two special or proprietary things. Now, let's talk about how to dump data. Let's go back to syslog. In addition to all the transformation, mprobe can also, at the same time, write data to various places. One is the disk. This is like -p and a path. Let's say -p home Luca flows, and it saves flows into the disk. I will show them more. Or can write the same flow in JSON format to syslog. Why syslog is important? Because there are many sources of data that are able to listen to syslog. So for instance, if you are familiar with Elastic, there is a tool called logstash. So this one is looking at the log file. It is also able to look at the JSON, syslog in JSON format. So some people want to ingest data into Elastic using logstash, because logstash allows you to put extra fields or filter flows. It's a versatile, let's say, ingestion. So in this case, they take this data from syslog and send them to Elastic using this tool. So JSON, let's say, and syslog are a way to, let's say, make happy several tools that otherwise would have problems to handle those flows. Okay? Now, the idea was to run some practical session together, but I don't know if you want to do that at this time. So let me show that at least a little bit. I put this color so you can see if you are sleeping that there is something different happening. So let me do a quick demo. So let's run in probe mode. So say mprobe -i en0, that is my internet interface, okay, where I'm connected to the internet. Specify B2. B2 is creating a verbose dump of what is happening. Okay? So it's starting up, and every time there is a new flow, it creates, let me stop scrolling. So every time there is a new flow, probe reports it, creates it in memory, does the analysis, and then at some point, when the timeout is over, the flow is emitted. Okay? If you now kill it, you will see those flows are emitted. Okay? And this is done live, while I process traffic. So I can do this, mkdir/tmp Luca, mp/p tmp Luca, t3, v3. So these are the two timeouts before. So I create very short flows of 3 seconds, just to, let's say, be quick. Okay? So this one is creating flows. If I start surfing the internet, let's say, let's open a newspaper, we see many flows are created. Okay? Now if I Ctrl+C, inside TMP Luca, mprobe has created a hierarchy, so 2023, September 21st, 5 o'clock, and then various files with minute 11, minute 12, let's say minute 11. Inside this flow, okay, source address, destination address, facility port, packet, bytes, and so on. Of course, I can generate them in JSON. You just have to put the JSON back. And probe can, at the same time, write to disk, send to Kafka, send to ZeroMQ, send to JSON, to syslog in JSON. All those things are possible. You can combine all of them. So once the flow is in memory, it can be exported in various ways once. So the packet is analyzed one time and then emitted multiple times. It's up to you. You can play that on the command line. And of course, you can use ZeroMQ to speak to ntopNG. And you can click.
Does change or can be done the same?
Yes.
We can export that for information and at the same time 0 to another.
Yes.
Okay, that's good.
Yes, you can. Other questions? Okay, back to right. Now, I told you, there is something here. Eventually, here we go. I will tell you in a second. So, no, let me go to one slide before. Yes, this one. What is dash T? So in NetFlow, when you export data, you can be flexible. You can say, I want to export only this information. I want to export more information. So in essence, in NetFlow version 9 and later, before exporting data, the probe says, this is the template I'm going to use. So from now on, all my flows will be formatted according to this template. A template specifies what is inside your flows. With dash T, you specify the template. How can you do that? So, in nprobe, when you type nprobe-h at the help, okay, it's a long help, and then at some point it shows all the information elements. Besides technicalities, such as this one that you can ignore, look at this label. Okay, this one says, if you want to export incoming profiles, you have to use percent in byte, outgoing percent, sorry, incoming packet, and so on, and so on, and so on. So with dash T, you can concatenate all these items, saying, I want to export, let's say, number of retransmission, TCP retransmission. I want to export this and that. And simply with dash T, you have to concatenate them in a long string, saying, I want to export this data, and probably will export this data. And based on what you want to export, nprobe will enable or disable some internal engines that, of course, require some CPU. Let's make an example. If you want to export the TLS name, so the SNI, so the name of the host inside the HTTPS connection that contains the destination host name, nprobe knows that it has to decrypt in a way, because the initial negotiation is not encrypted, of TLS and extract this data. If you don't say that, it simply ignores TLS. So a template is a way to define what to export and what, of course, is the format. So another example is this one. So if I've shown you something, let's add something else. Okay? Let me show it again. So this is an example, okay, of the standard nprobe template. The standard nprobe template is the one that Cisco is using, exactly the same. So before source destination, SMP, blah blah blah. Okay, but suppose I want to add something else. In this example, for instance, I added the transmission, the number of bytes that are being retransmitted. Okay. Or I can put other things like nprobe-h grep L7. Oh, sorry, grep L7. Okay. So, for instance, there is L7 protocol. As a number or as a string. Let's add the protocol name. Okay. So I run the same command before, say -t. Okay. And I can put, let me copy this template, and put this one, and then I put at the end, for instance, the layer 7 proto name. So I have modified the string, modified the template, okay? Nprobe starts, and then at some point let me do another refresh. So let's now stop. Okay, now it's 1718, so let's take. As you can see, so this is the new one. And this is the old one. So in the old one, there was just the standard template. In the new one, it transmitted by, in and out, and for instance, the protocol name. Yeah, why is that? Because I have VPN in my office. Amazon, I don't know, it's everywhere. TLS and so on. Okay? You see, TLS, some and DPI is able to also detect the trackers. You have some trackers on my web page. So, various things. Of course, I can add other information elements such as the. So what is the domain name that has been queried? So with -d you can put that. Because this is nice, it's flexible, it's whatever you like, but it's complicated. So what we have done is the following. So for ntopng, we have done this one. So we have some shortcuts, okay? So ntopng means use a template that ntopng can understand. It contains a lot of information. So that you have to specify them one by one. Let's do it again. So as you can see, there are many more information elements. So for example, there is the TLS7A, there are the risks, okay? So why, pattern of port. So it's more, there's a content, like name. So with -d you can specify that. Through NDPI, this is the coding, let's say, is one. It's an advertisement of my host through Informaticas. With -d. So if you want to analyze the latency, you can search for latency, layer 7, FLE, very simple. Now, another thing is that you can aggregate flows based on certain criteria in memory. So for instance, there are many companies that are using, because of the nature of the network, two VLANs. Okay? So let's say, when you monitor the traffic that is leaving the network, you can see VLAN 100. When it's entering the network, maybe VLAN 200, because then the VLAN are regioned maybe later in the network. But we are in a mirror port that is in a place that is not super convenient. So in essence, you can say through aggregation, ignore specific fields and delete them, because otherwise you cannot put the flows together, because in one direction to be one VLAN, the other direction will be another VLAN. So aggregation is a way to improve. Whatever you receive from packets, ignore certain fields. So if there is 0, there are positional arguments. Like 0 is not the protocol, IP, port, QoS, things like that. Now, how data is delivered? So usually the probe is sending data out. So this was designed by Cisco. So the probe has a limited memory, it's run inside the router. Okay, as soon as the information is ready to go, it has to be sent out because I have to free the memory, because the memory is very little. So the router is exporting data. And that's fine. Unfortunately, the router often is on the internet. Sometimes I would like to export data to my host that is behind a firewall. So in this case, I have to put my firewall, sorry, my collector on DMZ, open the root, complicated. So with mprobe over 0 we have decided that to revert this. So by default, when you use 0 if you use -n for exporting the flow, it's like net flow because it has to follow the standard. But if you use 0 in essence, what it happens is that it's done the opposite way. So in essence, nprobe is not exporting data, but it's ntop that is going to nprobe to receive the data. So the initiator of the connection is ntopng, is not nprobe. So this way you can keep ntop behind a firewall and nprobe on the internet. Of course, you can use this flag to go back to classic IPFix mode. So let's say the message is the following. Whatever you want to do, we support it. We are flexible, either the classic way or the reverted way. If you want inside the nprobe package, there is also a package, a tool that is acting as as a proxy, and it's doing this, or into this thing. Suppose that you have a root entity, okay, and suppose that you have the cholesterol here inside. And this root I want to send flows to here. So we have a proxy that is collecting the flows, that is delivering various few ways here. So part of the ntop package, there are all the options to massage the data. Whatever architecture you have, you probably have the solution for you. If you are behind an ATA file, whatever, so there are flexible way of doing that. So I don't want to make you this exercise, but in essence, it's possible to add a probe mode or no probe mode. So in this case, ntopology connects to a probe to fetch data. In the other case, ntopology does not connect, it's a collector, and receives data sent by mprobe. So according to your NAT roots, you whatever, you decide which one you like. As I said, mprobe contains plugins that are a way to dissect the specific traffic deep. So for instance, for HTTP, that is a popular protocol that everybody knows. For instance, it's possible to extend URL, URL agent, all the various fields. And this is kind of simple, so in essence, HTTP. Nice things happen when we have protocols that are more, let's say, special, okay? Let's make an example. One of the things we have done this year is monitoring of Zoom and Teams call. So you have Zoom, okay, you have a Zoom call, and you want to know from the network standpoint if everything is in good shape. So let's say I'm a network manager, my network is working fine, so if the quality is bad, it's because of your laptop that is old, like mine, that you have to replace. Things like that, okay? And the same for Teams. You will see again tomorrow the talk from Catchpoint that can explain how mprobe has done that. So in essence, we have enhanced NDPI. So in NDPI, we are able to distinguish between a call or the standard Teams protocol, chat, the standard Teams, and in case here we have some video. In mprobe, okay, here we detect it. Say this is a Zoom video. Here with mprobe, we are able to go deep into the packet and to understand, for instance, the quality. In RTP, so this is the protocol behind the Microsoft and Zoom are using extensions to RTP. So we had to do some, let's say, some tricks, okay, to understand that in a special way. It's possible to characterize the protocol with something called MOS. MOS stands for Mean Opinion Score. So many years ago when telephony started, in order to understand the quality of the call, human operators were listening to phone calls, creating a score on a paper, saying, okay, this was good quality, this was bad quality. Okay. Over the years, this is kind of illegal, blah blah blah. So they do it in an automatic fashion with MOS. Okay. So this is a number that says how good is the quality of the call. So mprobe is able to compute that, and we have extended handling this special RTP also for Zoom and Teams call. And now, if you have an ntopLG, if you have this, note that I also split the Skype here. It's not a mistake, because much of us acquired the Skype years ago, and it's using the same protocol that Skype is using for Teams. So when you have Teams, it's the same protocol used by Skype, right? That is it. So we're able to see, for instance, if this is on the stream, if you are sharing the stream, audio. So Alfredo knows that we have some users that are very, let's say, upset because they have very little bandwidth. So we can run an edge in a way so that we can block, let's say, video stream, but not audio and screen sharing. So we do all these kind of things, kind of tricks, just to okay, the problem is the bandwidth. We have the bandwidth, but we try to survive this way. And for each stream here, we detect them, and we also know the quality. Again, we will see tomorrow from Catchpoint to see that. So we can tell you if the quality was good enough from the network standpoint or not. This is because of a plugin inside mprobe that is able to dissect in deep this special RTP stream. Another thing that not many people know is that mprobe can act as an IPS, intrusion prevention system. Probably the word is too strong, but I will now tell you what it means. So it's a bump in the wire. So in essence, there are two network interfaces, and the traffic is flowing from one interface to the other. So let's say from LAN to WAN. Okay. Because we support also FreeBSD European trends, in this case it's operating in a little bit different fashion, because in FreeBSD there is a layer, network layer called netmap, that in essence allows us to be in the middle of one interface, let's say the one, and decide what to do with packets. So let's say this is the idea, but the implementation is changing between Linux and FreeBSD. Okay, but the result is the same. So in essence, in mprobe you can specify, okay, the network interface. I can specify a configuration file that allows you to say, for traffic on this interface, apply this policy, okay, on the traffic. And this one is based on DPI. I will show you one example. Okay, first of all, you define your pool of hosts. Let's say localhost, remote host, printers, whatever. You can specify for each pool a policy. Let's say you have a marker, okay, and the default marker is pass. See, in this case the default is pass, okay, and we allow, for instance, some basic policy like Italy pass, China drop, US pass. Okay, this is the default. If no other rule is matching, this is the default. So no China, for instance, but yes, US, yes. Then you have a different one. Let's say rule number one. Let's say I think there's a number here. Okay. So this one is called marker. Okay, because we have pass and drop that are the markers. Let's say pass, send it, put it, drop it. But let's say also how fast it can pass. So you can specify pass or a number. So in this case, for download the file transfer will be number 8, for media streaming number 9, and so on. And with a config file, you can specify number 9 means 10% of the value. Okay? So because mprobe is not shaping the traffic, mprobe is marking the traffic. Mprobe tells the operating system, I want to have file sharing according to this marker. And then it's the operating system, Linux for instance, underneath, that is doing that. mprobe is able to do only things like pass or drop. So DNS drop means no DNS queries will pass. Okay, for everything else, mprobe sits on top of the operating system. Anyway, these are details. What I want to say is the following. In IPS mode, you can use mprobe not just to monitor, but also to block traffic. And there is a user interface inside ntopng that allows you to configure this from remote. Actually, there is also another user interface inside the OPM sense that allows you to do, let's say, a simple configuration. So to have the full configuration, you need to edit the file, but to have a simple configuration, you can use that. Things like, drop me. I told you that DPI has risk. Okay, drop me, for instance, malformed packets, institute packets, or drop me selected protocols. Very simple things like yes or no are handled this way. Otherwise, you have to go to the command line. Okay, for drop me traffic to Asia or drop me traffic to specific countries. Okay, when the war started in Ukraine, many people said, "Oh, I want to block traffic from Russia, from Ukraine, from." But you are here and edit. Okay, so very simple. There is something to say. Okay, these are two different machines. Okay, this is a very, very cheap one. This one is, it's a low end, but it's a server. The speed of the implementation of mprobe depends on the operating system, because inside Linux, okay. So if we only do bridging on this implementation, we are able to do for IPS more or less the same speed. Okay. In FreeBSD, the story is very different, because I told you we have netmap. Netmap requires that every packet is analyzed. Instead, in Linux, it is not, because in Linux, in essence, mprobe receives traffic only for the amount of packets that are necessary to it to decide. For instance, if mprobe has to decide whether certain traffic can go to Europe, yes or no, one packet is enough. But if mprobe has to decide if a music stream like I don't know, Spotify has to pass or not, it has to receive a few packets. As soon as mprobe on Linux decides yes or no, tells this to the kernel, and the kernel will not send any further packets to mprobe for that flow. Because we made a decision. The decision is that. In FreeBSD this is not possible. So it means that every packet has to go to mprobe and back, even though we have already decided. And this long process is somehow just, explaining why we don't wait. So BSD is faster than Linux. It's in computing. But as soon as you enable that feature, the performance will go down. Okay, many people are very happy with 120 megabit. I don't want to say it's bad. But just to say that we have this problem. Instead of this machine, we don't have any problem. We're almost at the end. Don't worry, I want to be in time. Okay. mprobe as an agent, I told you before. I showed you the demo with the ntopNG flag we are developing. So if you have --agent at the end of the flag, mprobe is also monitoring the machine where you are, and it is exporting this information to the collector. So it's able to create things like that because it gives me the IP addresses, the process ID. Of course, if mprobe is running on this machine, you know the process on this machine. But because it's talking with a remote machine, it does not know the process on the other machine. But if you have two mprobe, one on the first machine and one on the second machine, you will see, let's say, that ntopNG is talking to whatever process. But you need to have the agent on all the machines. Otherwise, you will see only the one that is exporting the data, because this information is coming locally. And based on the agent mode, you can also add some rules. You see here, there is a drop. Okay? So there are some rules. So why do we want to drop this traffic? One of the things you can put on this config file is drop the traffic from applications that are not part of a package. Because ntopNG is in my home directory, is in my development place. mprobe says, okay, but this application is not part of a package. So probably can be a malware, can be something somebody has installed on this machine. Or you can put other restrictions such as don't run applications that are running from special directory, like /tmp, var tmp. No, those places where you should not keep binaries. So if you are in IPS mode, this one will be dropped. So ntopNG traffic will be dropped. But again, agent mode makes sense if the application is running on the same machine where mprobe runs, because otherwise it has no process visibility. Yeah, this is very important. And of course, you can see that in a graphical way showing in ntopNG. We have to find a better icon because we are using important and this icon a little misleading. So we see exactly this way. IPv6, 125, this is the process, this part of the bench process. Now the very last topic of today is the following. Some users told that they have sensors, IoT sensors, in the country. So having a port mirror is a problem because they have sensors here and there. Those sensors have usually very limited resources, very limited. Modern ones are able to run containers, very simple containers. Tomorrow you will see, for instance, a company that will present in the afternoon our tools and probe running on a switch, Cisco switch inside a container. But these are powerful machines. Imagine you have a PLC, a modern PLC, okay? They have a small containers, for instance, Wago is creating them, small containers based on ARM. So you cannot really put mprobe into the PLC because mprobe is small, but it's not small enough to do that. Also, PLC is not making a lot of traffic, but you want to monitor that one. This is a use case. But suppose you have one host remotely on your network that you want to capture traffic of this host, but you want to have a complete port mirror, packet broker, complicated environment. So last year we have created this software tab called ntop. So a network tab, you know what it is, right? But this is software. In essence, we want to have access to packets. So mprobe give you information but in flow format. Here I want to give you information in packet format. So I want to be able to capture packet on a remote end, on the PLC itself. Okay? And why you need that? First of all, you need to collect packets from a remote location. Or you want to do troubleshooting, so you have a colleague in a remote site say, I want to capture traffic of your host. Okay, instead of doing complicated things, simply run ntop, will show that how to do it, and we'll be happy. Or you have a distributed topology like the IoT, I told you, where doing mirroring ntop will be way too complicated. So ntop in essence is based in two components, the remote and the connector. The remote has to run at the remote location. So in my case of the Vago PLC, you put inside the PLC a container with this guy. It's a very simple application, a few qubits. You put it there. And this one is delivering packets encrypted to a remote collector. The remote collector is one application you run on your PC, Linux for instance. And it's creating a virtual internet on the host. So here you will see DETH 100. So whenever you attach, for instance, Suricata or Wirecard this Ethernet, in essence you're capturing packet delivered by this guy. So you can have one visual interface per remote devices, remote site from which you're capturing traffic from. Okay. Another possibility is this one. This collector can quickly open this switch. You know, it's a popular software switch. They use virtual machines, makers. So what we do is the remote speaks with this one that talks with the open switch and is marking traffic with a VXLAN tag. So because this is a real switch, in software it's a real switch, here you can have multiple ingresses so that you can do a port mirror, say mirror traffic of a remote host or mirror packet back. So it's a very versatile system. But anyway, this is a ntop remote that they run on a host, on a virtual machine, or a container. And this is the collector. Nice, but it's a bit complicated. Okay? So we did a simplification. So in case of our tools, inside our tools, the collector, okay, the collector does not require any license. The collector is embedded inside the ntopng and nprobe. So in case you want to have, let's say, in a country you have several ntop remote that can deliver packets to ntopng or nprobe without this guy. So it means that with ntopng or with nprobe you can collect traffic from remote places, just deploying this one on the remote end. So let's say, suppose you have your colleague in southern Italy that wants to send you traffic because he need troubleshoot. You say, start this one, no license, nothing, just software, free software. You put it there, and this one is delivering data to you, and you run the collector, creates a visual interface, or you can say, this one that is using a destination IPM port, I will show you in a demo, is sending data to ntopng. Let me show a demo that is probably easy. No license, So you start ntop remote, so a remote location, and say, capture traffic from this Ethernet interface, and the collector that will be receiving these packets is running on this host and this port. And the encryption key is hello. I use a very simple encryption key, and this is another problem. And then you can say to nprobe, blah blah blah, and say also collect packets from ntop hello. So this port, the collection port, understand that these packets are not flows or as flows, but they are from ntop, and decrypts them using this password because we have a symmetric encryption key. So this way you don't have to do anything but run this one remote, and this one is collected. So if inside your company you have multiple locations, you can deploy multiple remote that send traffic to the same one. It's efficient. Some people complain, but I think it's efficient because we can do 400 megabit. I don't think it's too bad because it's doing compression and encryption. Without encryption it goes a little bit faster, but it does still to compress traffic. Okay?
What kind of encryption?
Schinken. Do you like it? The Germans know that it's not bad. Okay, this is something that you already know. I will show that later. So tomorrow we'll talk about that again. But this is the way to go. So in essence, if you want, you can put a remote app that is talking to a remote probe that is talking to a remote ntopNG. All the things are possible. Okay.
Nella struttura che ha potuto prima è possibile è possibile fare un'analisi in tempo reale di quello che accade nella struttura remota, ripartito nel nostro un po' prendendo
Oh, okay. The question is whether this analysis is like a net flow where you pack some traffic together or not. Yeah, the analysis in real time. Packets are delivered in real time. The only thing is the following. We had a small delay of a few milliseconds. Very few. Just to say that if you are sending me more packets, se mi stai inviando pacchetti piccoli come un app, un pacchetto, aspetto un attimino, però 2 millisecondi, 3 millisecondi, poi li mando. So in essence we introduce just a little delay to pack together packets that are very close in 2-3 milliseconds maximum delay. So this to save bandwidth. Because if somebody is doing an app, we want to send one packet. But we want to have a real-time analysis. Because 2-3 milliseconds is not a problem on a link. Quindi è real-time, ma quasi real-time. Any question?
Yes, I have a question regarding the improved analysis. Is it possible to, I don't know if it makes sense my question, but is it possible to have dynamic configuration passing control? If you go on the left side, here you say that you use the NPS mode, but the NPS configuration. Yes, exactly. So, is it possible to change dynamic configuration by
Yes, for this is the ntopNG. So yeah, we have a ZM channel where we can publish, let's say, configurations like this. So we can send updates. So the answer is, if you use a command line, no. So that's it. If you use ntopNG, ntopNG can update it dynamically. We can do kill -1 to do that, but it's nothing more than that. So you have to do explicitly do the kill. Okay. And up. Yes. This one? Yes. This one? No. One per interface. Yeah, one per interface. I tell you why, because every interface has its own encapsulation. Because the first thing was the first version was able to do that. And then somebody did -I, loopback, and Ethernet 0. So, it's better to have 2 versions, one per interface. Now you can run, you don't need any license, so one each. More questions? So I want to see a winner tomorrow for the capture the flag, because I want to make Ivan happy. So spend some time making the CTF, because tomorrow we bring a small prize here, okay, award, whatever. And that's it. So I thank you very much for being here today for the first day. We record these videos, put them on YouTube after the event. And see you tomorrow. Thank you.